to you, Dasan.
Before we move further, I would like to explain to you functionally of today's workshop. We will be hosting a live Q&A session to answer all of your questions. So please make sure to drop in all of your questions and comment through our Q&A platform, Pigeon Hall, throughout the workshop. You will find the link in the chat box below. I would also encourage our participants to vote on any question which might be interest to you, so we can provide a higher priority to them. Due to the time constraints of today's events, I would like to apologize ahead of not being able to entertain all the questions. Furthermore, a feedback form link will be published during the workshop on the obtained feedback on how we can do better. Over to you, Sabrina.
Now it's time for the most awaited segment of today's workshop on product designing. Before inviting our guest speaker to take over, I would like to provide a brief introduction on our speaker tonight. He is a mechanical engineering graduate from the University of 𝘬𝘓𝘶 and holds a master's degree in industrial and systems engineering, ergonomics from Ohio University. He has over 5 years of experience as a design engineer and is currently the Director of Engineering Services at 𝘭𝘠𝘕𝑤𝘕. We are honored to have such an individual join us in the TechnoMind workshop series. I now invite the guest speaker for today's workshop, Mr. 𝘭𝘪𝑒𝘏𝑔𝑢𝑛𝑛𝑤𝑎𝑟𝑑hana, to take over the session.
Hey guys, thanks Sabrina, appreciate it. Thanks for inviting me. Can everybody see me and hear me properly?
Yes, sir, we can hear you well.
Okay, you don't need to call me sir, just call me 𝘭𝘪𝑒𝑘𝑒𝑚. All good. Okay, perfect. Thanks for the opportunity to talk here, and I really appreciate the fact that you guys put in a lot of effort to do this. And it just blew my mind that when I first came in, when you guys are presenting and all that, it's oh wow, these guys are super serious about this. So I really appreciate the opportunity again. Okay, so let me just I prepared a couple of slides for you guys just to go through today. This is going to be 40 to 1 hour, 40 minute to 1 hour session or something like that. So let's try to go through it. It's an organic session from my point of view. So I'm just going to elaborate some of the things that I prepped for you guys last night. Let me just share my screen and then I will go ahead with it. Okay. Screen. Share. Can you guys see my screen? I'm guessing yes.
Yeah, we can see it.
Okay, perfect. Right. The session is going to be broken down into maybe 2 sections. First is the introduction, the same old type of stuff, and then I will just talk about a couple of points that I want to give with you. Right. So move things away so that I don't have visual clutter. Okay, so we're going to be talking about product design and development. This is a subject area that somebody can be talking about for years and years, because everything around you is something that has been designed or developed by somebody, right? So your clothes that you're wearing, the table that you're sitting in front of, or the computer that you're using right now, those are all products, and somebody had designed it and developed it, so we can talk about it. Hopefully I don't need to do that in that detail. it's just going to be an overview of like some of the things that you can do today. About me, thanks for the introduction. So just like a very quick intro about myself. Look me up in like LinkedIn, add me in LinkedIn. I'm originally obviously from Sri Lanka and went to another college, then went to University of Morotua, did my mechanical engineering degree. Was there for like a couple of years, working for a shipping company called 𝘬𝘯𝘰𝘥𝘆 as a management trainee. Moved over to Singapore, used to work for Toshiba for a couple of years on their point of sale systems. Then I wanted to learn more about like ergonomics and then human machine interaction and those kind of things. So I went to the US, did my master's in industrial engineering along with my wife as well. And then when I was there, I started an internship at a company that makes lamps for Honda. And then soon afterwards, I was working for Honda R&D. There for a little over a year. So I worked on the 2016 Honda Civic upper body design. That was all good. Then went back to Singapore for 5 years and then joined this company called Dyson. It's not a famous company in Sri Lanka, but it's a very famous company in the rest of the world. Like everybody knows Dyson, the kind of place. I will give some snippets of that later in this presentation. Then afterwards, moved back to the US, now in California, now working in San Diego for a company that makes luxury products. So the 𝘭𝘕𝘂 Wellness company is part of a big group of company called Masco. I think they're like a $10 billion plus group of company. And I'm the director of all engineering services. That means tooling, testing, configuration control, compliance, and all of those good stuff. So that's a bit more about me. I think all in all, I think 14, 15 years of experience, master's and degree. Okay. Moving on. So this is an inspiration. Whenever I like make a presentation, I try to like just showcase a couple of things that I'm really interested in. One on your left-hand side is Spot and Atlas from Boston Dynamics. I love what they do. They are part of a Hyundai corporation right now. So they make the most humanoid robots that the world has ever seen. If you guys don't know Boston Dynamics, I highly encourage you guys to like look them up in YouTube. Just go to their website and check their content. One of the best technological companies that I've seen, and their work is awesome. Like most of the time, like literally like jaw-dropping stuff. And on the right-hand side is Tesla's Falcon boosters landing. SpaceX's boosters, they return back to the Earth, and then you see two of the boosters land in there, and the third booster typically lands on the middle of the ocean. From a mechanical control systems and dynamics point of view, this is out of this world when it comes to like these kind of like controls. It's extremely hard to do this, and most people do not appreciate this. So there's a couple of inspirations in my head whenever I talk to somebody else. I would strongly urge you guys who are listening, you guys and girls who are listening in, to have these kind of like inspirations, so that whenever you're doing something, and you can always say to yourself, oh wow, there are people who are doing these kind of crazy things. Whatever I'm doing should be easier than whatever these guys are doing. Just level yourself up and just give you the confidence to say, yeah, if these guys can do that, I should be able to do this, that kind of thing, right? Can you guys still hear me, Kasun? You guys are still there?
Yeah.
Okay, right. And if I'm like if I'm talking really fast, if you want me to slow down, let me know, because as Sri Lankans, whenever we learn another language, you tend to forget that it's not a Sinhala Tamil, so we tend to like speak really, really fast. So let me know. Right. This session is not going to make you a Elon Musk or a Steve Jobs. It's a joke of the day. If we are that good, then I will probably not be talking to you guys over here. In case you were wondering, That's a picture of the Cybertruck with Elon Musk. I hope everybody knows what happened with like the Cybertruck. So the Cybertruck is something that Tesla made. Oh, they are going to be launching probably next year. So in their demonstration, like they wanted to showcase their glass, their bulletproof glass, and then their lead chief designer threw a steel ball into the glass, and then the thing shattered. So it was kind of awkward, but it was fun. He's not the most respected person on earth, but like he did do some crazy things, and then we really need to appreciate that he's a genius. Steve Jobs, obviously, everybody knows him. In person who made Apple, who co-founded Apple. Okay, but this session is about sharing some of the learnings from my experience, right? And as I mentioned over there, if you can walk away with like maybe 1 or 2 points, I think this session would be a success. Let's be realistic though. I mean, I don't expect you guys to be like taking notes or anything like that. It's just like listening and then just understand some of the things that go into product design, and then have a couple of key points. Like if you're not doing it right now, start doing it, that kind of thing. Habits that you basically develop over time. And it's, for the most part, at least in my view, like you really need to like venture out of Sri Lanka and then like go into like multinational companies. Or probably there are companies in Sri Lanka that do this, but like in my experience, it was not the case. And I've certainly learned a lot working under like different management systems like Japanese, American, European, those kind of things, where you learn all of this good stuff. Okay, now, first things first. I am thinking that majority of the folks who are listening in are in college, because when Kasun invited me, I was asking him like, hey, who are the people who's going to be listening in? And then like, okay, I'm going to guess now. So I'm guessing if I draw a non-normal bell curve, your average age would be somewhere around like 20-ish. And then you guys are still in college, and then you are looking at probably graduating and doing something crazy in your life. And then you are in that mentality where you want to like create stuff. So this is where you will basically come up with like ideas, like, oh, I have this cool idea I want to try out, that kind of thing. These are some of the things that you should probably be thinking about whenever you come up with an idea, right? So first things first, what is the problem? What are you trying to solve? It's very easy to come up with ideas, but the question that you would need to ask is, what is the value that you're creating, right? Am I really fixing somebody's problem, or am I fixing my own problem? And then are there any people who are like me out there that would benefit from it? Okay. Or are you, with your idea, are you trying to create a need? A simple example like Facebook, when Zuckerberg or whoever he stole the idea from created Facebook, there was no need, right? He just created a need, right? So it's either you fix a problem or you create a need. But the question is like, do you have a lot of people who have this need, or do you have like 1 or 2 people who have this need who would be interested in buying the solution or the idea? Excuse me. So if you can find a customer for your idea, how much is that customer willing to pay you, right? Is it going to be like 100 rupees? Is it going to be a couple of dollars? Is it going to be 100,000 or like $1 million for your idea, right? You need to understand that you need to have a very good idea of like how the customer is going to react to your product. And then the last one, has anybody tried this before? You should always question your idea. Like if it is, my manager used to tell me, if it is too good to be true, probably isn't, that kind of thing. So if you come with the idea, has anybody tried something along those lines? And then what happened to it, right? let's say I come up with this brand new idea which nobody had done before. I'm going to make this car that runs out of like solar power. Yeah. Probably somebody had done it before. For sure, people have done it before, right? So it's easy for you to like come up with an idea, but just need to make sure that you don't reinvent the wheel again and again and again. So you might be wondering who's this dude on the right hand side holding on to some weird contraption. The person that you see on your right hand side, that picture, is James Dyson. In the UK, they call him Sir James Dyson because he got like some honorary knighthood or something. Shouldn't matter for you guys. What matters is the way he thought about stuff, right? He is not an engineer. I think he's a self-taught engineer. I think his profession is like architecture or something along those lines. Now, he is the second or third richest person in the UK. And then the product that he's holding on to right there is the bagless vacuum cleaner, right? So this bagless vacuum cleaner really kickstarted Dyson, and the Dyson is famous for that. If you go to any place in the US, like anywhere in the US or most of the Western countries, if you say, or you work for Dyson, everybody like, wow, what did you do there, like that? So it's quite nice. So this was James Dyson's problem. I mean, most of the people in the Western Hemisphere or any place that they even have carpets on their floor, and that they need to vacuum the floor, right? So basically, you got a motor or suction pump that basically sucks in air from the floor, and there may be a couple of brushes in there to sweep up the dust, and then it goes to this bag, right? The bag that says Hoover, that's the company. So there were companies who were making this product where you've got bags attached to the vacuum cleaner, and then when you vacuum, obviously the dust ends up in the bag, and then the bag kind of acts like a filter, right? So when the bag is full of dust, you either dust off the bag or empty the bag, or you replace it with a new bag, which was the case for the most vacuum cleaners out there. So you basically buy bags and then throw them away. So James Dyson looked at this and then he was thinking, oh, this is a problem. I don't want to buy bags. Like, why do I need to use a bag? So he was looking at like inspirations to like create a separator. And then recently, like he had completed a cyclone separator for the grain industry. And he was thinking, wow, I could probably make that same have the same function using a cyclone separator, right? So if you go into a grain mill, you would see that when you want to separate the grains from dirt and like rocks and stuff, you basically swirl it around, and then because of physics, you basically have the grain separated from any other particles or debris. So there's a question. I could see a raised hand. Or do you want to take questions later on? Okay,
We'll
I'll just go ahead.
having a Q&A later, so they'll be able to put the questions.
Okay, sure. Thanks, Shagil. So yeah, so then he started working on this. On this concept where, you know what, I just want to create this cyclone separator for a vacuum, and then I'm going to eliminate the need for a bag. So this is a snippet from the Dyson.com website. After 5 years, after 5,127 prototypes, he created the first bagless vacuum cleaner, right? this was so successful, and then there were like lawsuits and stuff as well, like with who where he like there were like copyright infringements and things like that. But all in all, he created this company called Dyson, and then he became the second or third richest person in the UK. I've done design reviews with this person, and then I mean in the table, and then it's quite remarkable, like the way we approach things. The story, or like the learning point from this experience was that you might be looking at something and then be frustrated with it, and then you might see some inspiration from someplace else, and then like think about, oh, I could probably apply the concept that I'm using in this application into my problem, and then come up with a solution and then fix the problem. And as you can see there, 5,100 prototypes later, he managed to perfect it. So he's one of those people who would like just take some cardboard, like create a little funnel, put a motor on top of it, check out your concept, and does it work? And then like break it again, do it again, and keep repeating cycle. This is the mentality of that company. You are encouraged to make mistakes. I mean, not silly mistakes, but encouraged to try out design ideas and then learn from it, break it, build it again, break it, build it again, etc., etc., etc. Right. I love this philosophies. Because of that, whenever I am thinking about anything for my current employer or my previous employers, or even like on my day-to-day work, like if I feel like, oh, and this is a new idea, I need to try it, I would be sitting down with like cardboard and things like that and just like make prototypes, right? It's once you make a prototype, you can actually play with it and then get more feedback into what you need to do. This is the second portion of this info session. Now, whenever you have a problem, start writing it down, right? You need to define what is the requirement. So for example, in Dyson's case, James Dyson, his requirement would be, I want to eliminate the bag from the vacuum and have the same functionality of a bag vacuum, right? Write it down. Make this a habit. Whenever you have some idea, write down, start drawing. I will talk about that drawing later in the slide set. When you do this, you basically, you create content, you create things to talk about, things to review with other people. When you write down, you can read it and then be like, oh, wow, okay, is this the real problem that I'm trying to fix? Do I need to have additional requirements? It's the secondary requirements where I don't need to meet these secondary requirements. I just need to meet the primary requirements. The secondary requirements are like nice to have. Now, for example, secondary requirement would be for a vacuum cleaner would be a retractable cord. So a vacuum cleaner will have a cord connected to the outlet. So when you're going around, when you're vacuuming the house, the cord is like just dangling behind you. So it'll be great if my vacuum cleaner had a feature where whenever I'm like going back and forth, the cable automatically retracts back to the outlet, because it reduces a nuisance feature that is there in the product, right? So if you don't have the secondary feature or secondary requirement met, is it going to impact the primary requirement? No, not really. The primary requirement is to remove the bag. The primary requirement is vacuum the floor. The others are nice to have features. So you need to distinguish what is the primary requirement and secondary requirement in your problem, and then in your idea. When you do that, it becomes easy to think about your solution. You will get this if you practice practice certain design like product development tools like FMEAs, like failure mode defect analysis. This will come into play. I'm quite sure you're going to learn FMEA at some point in time. Maybe if you have some time, we can like talk about FMEAs like briefly. But yeah, that's something you should probably be doing. So coming back to the point, write down your primary requirements as the secondary requirements. It will help you guide yourself to the design and then ultimately develop the product. Right. So far, so good. So I can't see any of you guys. So
yeah.
Okay. Right. So once you write down your requirements, get a pencil and a paper and start drawing. This is something that I learned from Toshiba. My manager was very annoying, but I learned a lot of things from this person. Japanese manager is also Subo-san, that's what we call him. He would always encourage everybody, especially junior engineers, especially like people who just come out from college, to get a pencil and then a paper and then draw what you're thinking, right? This could be a drawing schematic of a product that you guys are looking at. This could be a robotics, like an assembly machine. This could be this could be like a app that you're thinking of. This could be a software platform, whatever. Get a pencil and paper, just write it down, draw it, create block diagrams, create content, right? If the idea is in your head, it's very hard for you to explain something to somebody else and then get feedback. The objective of one of the key principles of good product design is like getting feedback. So if you don't have something to review, you can't get feedback. Now, not everyone of us is like good in like drawing. It's okay, learn it. Learn how to illustrate something. Try to develop this ability if you are into like product design development, where you can walk up to a whiteboard and then you can draw whatever is in your head and then you can explain it, right? And then don't be shy about it. Just don't be afraid to pick up a marker or chalk or pencil or whatever. Just explain something, right? I cannot tell you how important this point is, because it had served me in so many times, like whether I was in like Honda, Dyson, Toshiba, even in my day-to-day work, like if I'm thinking about something, if I'm planning, let's say even the house renovation, whatnot, draw it. What you want to do, put it in a paper, and then if as a contractor, you can show the contractor, this is what I'm looking at. This is what I'm trying to create. Architects do this all the time, right? They get their thoughts into a paper and then like show it, right? Then the next point, try to create mockups. Now, mockups are things that resemble your product, but it's not the final product, right? So it could be, you could use like cardboard, paper. If you have a 3D printer, you can print something out of it. If you have somebody who knows a 3D printer, you can ask them to print something. When you create mockups, you get to play with it. Okay, let's say if you are trying to create a new, I don't know, tablet or like a computer, just make a cardboard box that resembles a tablet. Just play with it, feel it, move it around, like do things that you would expect to do with the tablet, and then you will understand some additional requirements that you were not familiar before, right? It's the first step. You need to move on, right, from the idea in your head. Then these days, everybody has access to like things like Arduino, Raspberry Pis, and things like that. Can you mimic the functionality? Can you get your mockup to function like the final product? But it's not the final product. Obviously, it's not your dedicated PCBs or anything like that. It's just something that gives you the impression of the final product, where you can show to somebody and get some feedback. You guys are familiar with like the term MVP, the minimum viable product, like get the base requirements out and then like create a product that can showcase the basic functionality. If you can do that, you are 10 steps in front of the point where you were before. Like from the idea in your head, you've already like gone halfway. Okay, so remember these points over here, especially the first one. Again, if you think like, oh, you know, I never studied art in my life. This is not about studying art. This is not about like, drawing something pretty. It's about being able to get your idea across to the person who's sitting on the table, and then you can review it. Okay. All good. Then you need to question when you come up with these mockups, when you create an MVP, when whatever the prototype, does it meet the requirement, the one that you wrote down before? If it doesn't, then the product is NG. NG is like no go or not good. So in product development, you will always find this term NG, like NG, okay or NG, no go or go, right? So if it is NG, you need to take a real look at your mockup or product, and then or your idea. Take a step back, break it down, do it again, go back to the paper, draw another idea, try it out, go back again, try it, test it out. Does it work? Get feedback, talk to other people. What do they think about it? Talk to people who do not have the same expertise as you have. It's always great to get a non-technical opinion about your product, and don't be judgmental about that, right? Because your objective is to get feedback. Your objective is not to be praised by somebody, right? Your objective is to make sure that you have a good product, not to make you yourself feel good, right? So talk to other people, and they might criticize the product. You might, this is worthless. Why do I want to have a bagless vacuum? I love my bag vacuum. James Dyson used to say, some customers don't even understand their requirement, right? So sometimes they say the customers don't know anything, right? But talk to them, ask them, what do you think? Did I just like solve your problem? How much money are you going to be giving to me because of this? Right? So find people who are able to give you constructive criticism on your product. And then if they give you criticism, you write those things down. You can get feedback from surveys. You can do voice of customer research and things like that. Just talk to people one-on-one is the best, and then get some feedback and then see what they think about it. Right? Literally, this is stage gate process in a nutshell. You have different stages. This is what we do, right? Whenever we develop something, we set up some requirements. We test it against the requirements. If the requirements are met, then pass to the next stage. If they are not met, you're stuck in the same phase, or you need to go back again. You go back to the drawing boards and to see if you have this figured out correctly. When I'm guessing most of you are still studying, but in college, I think you're going to be learning about stage gate process. So when you eventually go into the industry, this is going to be there in your face. This is something that I wasn't, how to put it, really compliant when I was in college, but when I went to Toshiba and those kind of places, yeah, it's pretty much a bread and butter on a day-to-day basis. Every day you're sitting in a meeting trying to pass a stage gate because your product is either failing a requirement or something along those lines. Right. This is an analogy that I try to push out. So are we trying to fix the right problem? Pops up all the time. Don't be afraid to ask this question. And then this is when you have situations where you actually try to think outside the box, right? This picture of a person climbing a coconut tree, and pretty much everybody has done it, at least like when I was growing up, maybe not for you guys these days. You just go to the shop and buy a coconut. So when I was growing up, like, yeah, climbing coconut tree is like, yeah, whatever, that kind of thing. So, but these days, you can't find people to go up with the coconut tree. It's expensive, and then it's risky, right? You can fall and then injure yourself. Obviously, some people die, and then you get paralyzed for the rest of their lives. So this is a serious problem. So people come up with like all these contraptions to climb with a coconut tree, right? Oh yeah, you'll have this little motorcycle that gets hooked onto the coconut tree, and then you can go up the coconut tree and then you can pluck coconuts now. You need to be able to think like, hey, what is the problem here? The problem is like people falling down from the coconut tree. The problem is the coconuts are at a very high altitude. Should we think about shortening the coconut tree? The height of the coconut tree is the problem. Can I modify the gene of the coconut tree so that the coconut tree itself is like short, so that I can just use a ladder to climb the coconut tree, right? So try to take, just sometimes when you are faced with a problem and then you come up with the ideas, just try to stop and just relook at the problem, and then like, is this a problem that we are trying to fix, or can we define the problem in a different way, or can we look at it like totally different? Like, yeah, if the climbing the coconut tree is a problem, make the coconut tree short, right? That's something that I think I'm going to encourage everybody to like just look at. It's easier to say than do it when you're in the heat of a meeting, or when you're in the heat of like just going through a project. These things don't really come up, but it's always good to just take a break from what you're thinking, and then let's just go for a walk and go look around. You might actually see a cyclone on the side, and they're like, oh, this might be the way to fix my problem, or maybe I didn't define the problem properly, right? One last thing, don't stop learning. These days, you have so many opportunities to learn stuff. I think this info session is like one of them. Try to listen to other people and then get feedback, and then try to improve ourselves. I'm late into my, can I say late? Yeah, might be into my career, and then I still learn every day. Every day, just learn something new. Never stop learning. If you are in college, I would highly encourage, and if you're into product design, if you want to come out as a product designer, I would highly encourage you guys to and girls to learn just a bit of CAD. CAD in this is like computer-aided design. These days, I think you can find like free CAD software out there. Learn it. Not the problem with like CAD is that you shouldn't be how to put it. Especially when you're in college, if you focus on just like one CAD software, like let's say SolidWorks or something, it's not that when you go to the industry you're going to find SolidWorks, right? You might find something as like CATIA, ProE, UG, or something along those lines. So learn the techniques of CAD, but not the CAD software itself. I mean, you can. I encourage you guys to learn the CAD software itself, but like try to understand the techniques of CAD. Like, how do you create a box? What is a sketch? What are the datums and things like that? So try to understand the logic behind creating CAD model, how to correctly structure CAD model, things like that. This could be mechanical CAD, this could be ECAD, electronics CAD. Try to learn it, because you are that more useful when you know all of these things, when you go into the industry, or when you try to create your own product. Who knows, when you want to create something, you want to create a plastic enclosure, and then you are an electronics person, and then you're thinking like, oh, this is not my expertise area, but it does not stop you from quickly getting onto a free CAD tool and then like mocking up something, and then wow, you have a product with you in your hand. You don't need to wait for somebody else to do it for you, right? There are times where you feel like, oh, this is too complicated. And then you really need to work with somebody who knows about something. For example, if it is a detailed PCB that requires me to like create a custom 𝘬𝘯𝘰𝘥𝘶𝘬𝘚 or something, I'll reach out to a friend who knows electronics, and then like just team up together and then get two brains to work together. Learn a bit of programming. Again, I'm not saying that you need to be like a programmer to the point where you know inside out. It's just like learn the basics of programming, like loops, variables, stuff, right? Then when you know that, like you can work with different ecosystems, whether it's Python or VB, or if you're creating a simple ladder program in a PLC, just learn the basics and then understand the fundamentals behind it, right? Then you can, when you're put in a place where you really need to learn something, then you like, oh yeah, since I know the fundamentals, it's very easy for me to pick it up, right? Rapid prototyping is one of the areas that's quite relevant these days. Pretty much everybody, most of the people who are into like product design in the Western Hemisphere or like in the Western world, like they have a prototyping machine at home, and then they can make plastic pieces and they can try out different ideas. It's very useful. I think most of the universities and colleges have rapid prototyping machines. I would highly encourage you guys to, if you're into product design, to familiarize yourself with prototyping, the basic concepts. How do you slice a part? How do you make a part and things like that? And what are the tools that people use these days? Like how to make a prototyping part, things like that. Soft skills. The point about like drawing something on the whiteboard or piece of paper, try to develop it. Try to develop your skill set to talk to some other person and then express your ideas and your viewpoints without taking things personally. Try to distinguish or like in your head, try to figure out, is this my personal bias or am I really getting some constructive criticism on a product? So those kind of things, try to build them. They are not something that you're going to develop overnight. It takes years. And then if you keep practicing it, just like a language, right? If you just try to study a language, like practice a language in your head, you're never going to succeed. You always need to talk to somebody or like just practice with some, I don't know, some app or something like that to get to the point where you can actually use it on a day-to-day basis. So try to develop those kind of soft skills. It really, really helps you. Especially, I'm busy, most of you guys are in college, so whenever you go to the industry, your ability to communicate to somebody really matters. So try to develop all of those things. If you think like language is like one of them, I would try to improve it as much as possible. There are tons of free courses in online platforms, Coursera, edX. Even myself, like I sign up for like courses and then like go through them. I would sometimes audit them. Sometimes I get the certification because certification really pushes you to complete the course. You paid for it, now you need to do it, that kind of mentality. Everybody's busy, but try to set aside some time to learn something new. It could be as simple as like watching YouTube. You know, there are tons of tech reviewers. There are a couple of really good tech reviewers in Sri Lanka as well. So there are some in like Sinhala as well. So I would highly encourage just to watch YouTube. Don't watch like silly things in like YouTube as wasting your time, like reviews and things like that. That really like teaches you something about like product design. Myself, I follow people like 𝘬𝘯𝘰𝘥𝘶, and then like 3D printing forums that will really improve my understanding of what is the latest tech out there. So for example, if I can't go to CES, the Consumer Electronics Show, see what they have through somebody else's lens, right? Like, so if 𝘬𝘯𝘰𝘥𝘶 goes to CES, then I want to see what he saw and then what are the things that he found interesting. So those are some of the things I would encourage everybody who's listening in to learn. I think that's it. I mean, we can go into like as in the in the earlier part of this info session, I mentioned that you can go into certain tools that you can use in product development. I don't know whether this is the right platform or the time to do that. It gets like super detailed, so but let me know. Right, that's it. I'll stop sharing. So if you have any questions, please feel free to let me know. By the way, like if you want to link up in like LinkedIn, add me in LinkedIn, and then if you want to drop a note, and then if you want to review something with me or something along those lines, let me know. I am keen to help anybody who's in Sri Lanka who's like trying to come to the product design. On a side note, Sri Lanka, like at least when I was growing up, we didn't have the industries to build products in Sri Lanka. I think I don't know whether that's the same situation right now. So, for example, if you want to make a product, you need to have supporting industries. But there are other countries nearby. That's why you see people like go to Malaysia or someplace to make products and things like that. So, if you want to review something, I'd be happy to help. So, yeah, connect in LinkedIn and then just drop a note. Okay, questions? Can you guys hear me?
Thank you very much, sir, for sharing it.
Okay, no problem. Most welcome. Yeah, I might have gone a bit. I tend to talk really fast. I hope everybody understood what I was trying to convey. So.
Yes, it was very clear. No problem.
Okay, perfect. Yeah, I can see like my LinkedIn popping up now. Like, so people want to connect. Okay.
I'm certain that this was a valuable session for all of us. I'm sure that our audience has a lot of questions to ask from our guests. In fact, we have already received some questions from the audience. I would like to remind you again that you can use our Q&A platform, Pigeonhole, to ask your questions. You will find the link in the chat box below. We'll try our best to answer all of them. Okay, now it's time for the Q&A session. So, sir, we have our first question. Sir, what skills or tools should I sharpen if I go into the industry as a product designer?
This is a very broad question. And unfortunately, there's no like a direct answer for this. I would remember the things that I was like saying before, like you need to like learn, like continue learning, where you need to like learn your soft skills, learn CAD and this like that. I would encourage everybody to like just stick to that for now. If I had to pick something right now, I would say learn something like Python, just like coding in general. Pick a free CAD software that, as I mentioned before, that will allow you to like learn CAD. But the problem is like whenever you say, okay, imagine this. In your college, let's say you have access to something like SolidWorks or CAD, right? When you learn SolidWorks and then you go in depth with SolidWorks and then you go out into the field, and then if the company that you're working for is going to use CATIA or something else, now all of a sudden like it's another skill set that you need to learn. So that's why I say like when you learn something like CAD, try to learn the basics or the core concepts of CAD. When you learn programming, try to learn the core principles of programming. Don't try to like learn, oh, this new feature, etc., etc. Like just no, just learn the core principles. I would, okay, this is going to be important. Learn statistics. Okay. Most people do think like statistics. Oh, I don't want to learn statistics. Oh, like I don't look at a bell curve. And no, you need to learn statistics. You need to have a very good understanding of statistics if you're into product design. you will have situations where every time like you explain to somebody like you need like, oh, what is the probability of this failing? What is the probability of this customer like requiring this? So learn simple statistics. It could be covered in your college, or try to hang on to the knowledge that you are going to receive in your college, and then like move out to industry with that knowledge. It's really handy to know statistics, and then when you are talking to somebody who knows statistics, so you get like people believe you, and then I just want to work with you more as well. So yeah, I would say if you want to just pick some skills to learn while you're in college, I would say yeah, learn a CAD software, learn some programming, learn statistics as well. As I mentioned, learn some soft skills. Communication is important, guys. You have no idea how important it is to like just go to a meeting and then just explain something to other people and then like review your ideas and stuff like that. So yeah, it's a broad question. You can't single out an area. That's what happens when you basically get your bachelor's or your degree, and you go to the industry, and then when you learn in the like get some experience in the industry, and then you get expertise in a certain area, then you want to like master that skill set in your expertise area. That's when you do a master's or even do a PhD, right? Typically, I don't know whether in Sri Lanka this happens. Like typically, people just carry over, like just do your bachelor's and then immediately do a master's. I would do not encourage that. I would highly encourage people to just like get some experience before that, so that you narrow into like certain skill area. Yeah, I hope I understood. I answered the question. As I mentioned, it's a very broad question. There's no clear-cut answer, but try to pick some of the points that I've explained today, and then like just stick to that. Don't really narrow yourself into a certain area, especially if you're open to product design, and then if you're going to be working in like different companies, etc., etc. Okay, that's it.
Thank you, sir. So we have a second question from another participant of us. So I am a biomedical engineer who also have a degree in bioimaging as well. I would like to move into product designing related to bioengineering or neuroengineering. Could you please share some view?
Wow, it's a great industry to be in. There are a lot of breakthroughs in that area. The question is, I'm guessing you are in Sri Lanka right now. I think that's a very specific skill area that you're looking at. I would highly encourage pursuing further education. You would probably need to, if I were you, I would be probably looking at like moving to States or some European country, or maybe Australia as well, and Singapore, where they specialize in this type of skill set, and then learn and then get more industrial experience with that. It's like you wouldn't study aeronautics, right? Or like space engineering or something along those right? Aerospace engineering. You can't watch YouTube and learn all of those things. You need to like get the credentials. If somebody's working with you on like bioengineering and things like that, I want to see your credentials. So I would highly encourage you to pursue further education. Most of the folks that I know who are in this industry, I think they at least have a master's or PhD in that particular area. So you need to study more. That's a simple question, simple answer.
So, sir, we have a third question. What's the biggest challenge you face when you enter the industry as a fresh graduate, sir?
Very good question. Again, it's one of those questions where you don't have just a single answer. The biggest challenge you're going to be facing is that there's a sudden realization that all the things that you did in your college life were just like toys. And then like they don't really meant anything when you were doing it. And then now all of a sudden it means a lot. So when I was doing my, when I went through my final year project, I believe the mentality was complete the final year project just for the sake of completing it. So, and then getting a degree, getting the grade. I think that was a mistake on my part, and anybody who thinks in that line. You need to have the mentality where you're thinking about the final year project or any other project that you have in college as a potential opportunity to get some exposure to the industry, right? So if you're a fresh grad who were in the mentality of like just getting some grades, yeah, I'll be fine. Once I have the grades, so GPA, I'm going to show that to my future employer, and then he's going to be, he or she's going to be super impressed and he's going to hire me, and then I'm going to do so well because I had like perfect grades. That is wrong. That mentality has, like, the ship has sailed with that mentality. Now companies look for this. They basically ask you, yeah, I see all your credentials, but what are you bringing to the table? What kind of experience do you have, right? Even a fresh graduate, what kind of experience do you have? And then the only experience that you have is actually your final year project. That's the only thing that you can market. So if you did your final year project just for the sake of getting a grade, now you really don't have anything to market, right? So that will be the biggest challenge for any fresh grad, in my view, at least in the product design area. Then you need to like just prove yourself. You need to learn from like the beginning and all that. So when you do your final year project, see if you really question, like, are you really like completing a project just for the sake of getting a grade, or are you really trying to fix a problem? And then can you really build on top of that final year project and then like make a good product out of it? Who knows? You might be able to make a company out of it, right? So yeah, as a fresh grad, that will be the biggest the culture change from like learning to actually providing is going to be the biggest problem or the challenge that you're going to face. You're going to be working with people who are going to pay you money to complete the work that you are doing. This is not like college where you go to school, you pay your own money to get a degree, or like, who knows, maybe you go and they take a free degree. But the mentality is different. You're going to have a person who's going to be paying you, and then that person expects certain things out of you, and then you need to be able to like show up and then do your job. So that's a mentality change that you're going to have, and then that's going to be a challenge for you if you're not in that. If somebody's listening in who's in who's doing the A levels, I would highly encourage you to go out and get a job the next day that you pass off from high school. That's what I did. In the middle of my A level exam, I was actually sitting for an interview in a company in Colombo. And I remember the person who was interviewing me asking me like, so what do you do? I'm like, I have my physics paper tomorrow. And then he's like, what are you doing here? Because I want to work, I want to get the experience, right? So had that mentality. So when I went to college, I had some like experience already. I've worked for like 11 months already in the industry. I've seen what people are looking for in the industry. I was studying for my CCNA, like a MCP, Micro Certified Professional, in the middle of it before I started my college degree at Mortua. So that's so as I mentioned, mentality change is a challenge. There are so many things that you can do to stop it from being a challenge. And some of the things that I've done is like just try to be employed as much as possible. I never had a break before I graduated. 3 or 4 months before I graduated from Mortua, I was actually working full time at my shipping, like the asset management training. And then before I graduated from Mortua, I was actually traveling the world. I was been to like India one time. I think we were about to go to like Copenhagen, Denmark before graduation. So yeah, hopefully I answer that question again. It is a challenge. That mentality change is a challenge, but try to work in a way so that it doesn't become a challenge. Okay.
Thank you, sir. So we have another question from one of our participants. If we need to make a product which can withstand extreme heat conditions, what kind of 3D printing filaments should we use?
Okay, you should probably not be using 3D printed parts if you are going to have extreme heat, first of all. Typically, okay, not all printers can print high temperature parts, and then it really depends on the temperature as well. So let's say if you're looking at an application that is 200°C plus, I would say don't even think about 3D printing it. Like, see if you can like do something else, cast something, something along those lines. Weld a couple of metal pieces together and then make a fixture. There are certain types of filaments. You can just Google them for high temperature. But even them, they're like not rated for like very high temperature. So when you say high temperature, it's a very subjective term. When I say high temperature, I'm talking about like maybe like 900 or 1,000 degrees, and then most of the printed filaments are not going to last at 800 or 1,000 Celsius. But if it is something that you want to test at around maybe 50, 60 degrees, which to a certain extent is going to be high temperature if you're looking at your environment. I would say most of the filaments that you're seeing in the industry these days should be okay. I personally print with my personal printer like 𝘭𝘮 because it's a good balance between PLA and ABS. I'm going into like technical terms over here, but like I think the person who asked the question would already know what is PLA and ABS. So yeah, I stick to 𝘭𝘮. But if it is more than 100°C, you are going to see thermal deformation. You don't want to be playing with anything that is above like even like 100°C, in my opinion. Your print bed is set to 70°C most of the time. That itself is like very high temperature.
Thank you, sir. That was the last question for the evening.
Okay, perfect. So if you have anything else that you wanted to check with me, add me in like LinkedIn, and then we can talk about it. I will always try to help as many people as possible. Hence the reason why I'm sitting here. Yeah. Hopefully this inspired you to like create more products and then like just change the way we think a bit about product design and development. And thank you for the opportunity given to me today to present all of this with you guys.
Thank you, sir. And thank you very much for all our participants' curiosity and sending in so many questions. And also due to the time constraints we have in the event, we have to bring this session to an end. However, we will ensure to provide all the answers to the questions in the upcoming sessions. That brings us to the end of the Q&A session. I believe today was a memorable day and an immense success. A huge thank you goes to our guest speaker, Mr. 𝘭𝘪𝘏 for taking time out of his busy schedule and gracing us with his presence here today. Sir, to show our appreciation for the support and dedication you've shown to make today's session a success, the organizing committee of TechnoMind would like to issue a virtual token of appreciation. Thank you very much, sir.
Oh, thank you for this. Really appreciate it. Thank you.
In order to remember this moment in the future, we have a small request for our participants. Please switch on your cameras and join us for a photo. We will wait another 30 seconds for everyone to switch on their cameras.
So no one gets to leave if we don't take this picture? I'm just kidding, I'm just kidding. Asuni. Hey, Asuni.
We would like to request our participants to put on their best smiles. We will be taking the picture shortly after. Okay, 3, 2, 1. Hold on to that smile while we try to snap everyone. Okay, organizing committee, can you give me a confirmation if we snap the photo?
Let's take one more, Sabrina. There's a few more people
Oh.
switched on the cam. So let's take one more and then.
Okay.
Yeah, all good, Sabrina. Thanks.
Okay, thank you everyone for the picture. And over to you, Dasan.
Thank you, Sabrina. Tomorrow will mark the last day of TechnoMind workshop series. We have a very special guest join us, Professor 𝘬𝘯𝘰𝘸, Head of Department of Medical Technology, University of Moratuwa, to enlighten you all on the topic biomedical engineering. Finally, on behalf of IEEE Industrial Application Society Student Branch Chapter of SLTC Research University and Robotic and Rover Division of the Student for Exploration and the Development of Space Chapter of SLTC Research University, I would like to thank all of you joining with us today. We hope you found this workshop very useful. Thank you very much. I'm 𝘗𝘳𝘰𝘥𝘶𝘳.
And I'm Sabrina Salman, signing off until we meet next time. Good night, everyone.
Thank you.